Willis, who's a professional engineer and serves as the Colorado Abandoned Mine Land Program Manager for Trout Unlimited in Salida. He's been with TU since 2012 and focuses on restoration of lands impacted from mining, in-stream enhancement, soil and water chemistry, and stream channel morphology dynamics. Jason holds a BS in plastics engineering technology from Penn State Behrend and an MS in civil and environmental engineering from University of Pittsburgh.
Well, thanks for having me. I have the last coveted before happy hour presentation of the conference for the day, so I appreciate that. But I'm Jason Willis. I'm from Salida, Colorado, which has a wildfire currently burning about 3 miles away from my house. So a lot of the concepts and topics today rang pretty true to me, to hear a lot about the restoration techniques. But specifically, I'm going to talk about 3 things, just kind of an overview of what Trout Unlimited does with regards to mine reclamation, some case studies for phytostabilization, and then a partnership and incorporating some of those techniques with Snowbird on their property right outside of Snowbird, Utah. So jumping into things, what is Trout Unlimited's role in mine reclamation work? I didn't know that Trout Unlimited did that. I usually get that question 50 times a year. I actually just wrote an article about to our local paper summarizing what my program does within Trout Unlimited. Within my program, which focuses on abandoned mine lands, we look at watersheds that exceed state water quality standards. We go after grant funds, whether it's through, in Colorado, the health department has a 319 non-point source program funded through the EPA. National Forest Foundation is another grant that we usually go after, Water Conservation Board, and then the State Forest Service. We also partner with private entities like Snowbird, like I previously mentioned, Freeport-McMoran Mining, Newmont Mining, Tiffany and Company Foundation are some of the private partners that we usually try to go and generate projects with. They will give us that match, and then we can leverage that money and partner with federal, state, Forest Service, BLM, Division of Reclamation, Mining and Safety. In Utah, it would be your DOGM program, Division of Oils, Gas, and Minerals. We represent the mixed ownership group in Colorado, which is kind of an accumulation of federal, state, and NGOs like we talked about today. And we fill that nonprofit role of the mixed ownership group. By filling this role, we are able to bring alternative sources of funding, like I just mentioned, flexibility in contracting. It's easier for me to get contracts in and out of the door, usually a lot quicker than federal land managers. We have the engineering experience in-house to deal with and assist with project development. And then we have collaborative relationships with federal, state, and private partners. It's really easy for me to work with private landowners and kind of sit down, have coffee with them. They're more willing to work with us on a lot of occasions than with some other partners we might work with. So some program expansion. Over the past 5 years, we've kind of taken on what I call a cradle-to-grave engineering approach, where we'll take on a project design from conceptualization. Engineering will take on the contracting, management in the field, oversight, and then post-project reporting. Whenever I started in 2012, we had the Kerber Creek project, just one project that we were kind of administering a grant for. In 2016, 2017, we averaged about 6 to 7 abandoned mine land cleanups per year. In 2019 and beyond, we're looking at active work in Colorado, expanding to Utah, Wyoming, and then some work in the Black Hills of South Dakota with core mining for some partnership opportunities. Some stats and numbers. In 2016, we had 1.238 million, 550,000 in 2017, 850,000 in 2018, and this is just construction costs alone in Colorado for abandoned mine land work, no overhead or indirect. And then all these projects focused on improving water quality, mine reclamation with components of stream restoration and revegetation. So I kind of started the talk and mentioned phytostabilization and how this is important to abandoned mine sites. And what is phytostabilization? The definition is an on-site technology incorporating calculated amounts of amendments and metals-tolerant plants to reduce soil toxicity and meadow mobility. The objective of this approach is to establish a self-sustaining system that does not rely on artificial inputs and provides nearly the equal ecological value as an undisturbed landscape. So amendment incorporation basically chemically precipitates or sequesters those metals by complexation or sorption mechanisms in the tailings or the soil. But what does that mean? It basically means that metals and their availability to plants are minimized, as well as metal leaching to groundwater is also minimized through this process of phytostabilization. So what is the role of phyto at abandoned mine sites? There's over 500,000 abandoned mine sites in the western US. There's 23,000 abandoned mine sites in Colorado alone. So the bare tailings and waste rock that are present represent a loss of habitat that could be used for either development, for recreational use, and then it helps eliminate non-point source contamination of heavy metals that are usually left over at those abandoned mine sites. And whenever I say waste rock is usually the rock that is pulled out during the development of the mine from the adit or shaft. Tailings is usually processed, or it can be sometimes more contaminated because the metals are more densely represented in the tailings material. So I'll just use tailings and waste rock interchangeably through the presentation. But there's usually high cleanup costs associated with repository construction. And a repository is basically an engineered facility where you might take tailings or waste rock from a contaminated site and put it into a repository that would have a liner. It might be unlined, it might have a clay liner, but it would be then capped with clean fill. Another problem with the repository is you have to not only revegetate the site where you're pulling the contaminated material, you have to revegetate the repository itself. So it can be anywhere from $30 to $100 per cubic yard to create a repository. And that number's a little old, it's gone up since then. So how do we incorporate phyto at a site? We do this by these amendments that I mentioned. Mixing amendments and establishing vegetation to limit exposure pathways and neutralizing the soil and reducing erosion. There are calculated amounts of lime and limestone based on the pH and the acidity present in the tailings and the waste rock. And what we have done in the past is, I say lime and limestone, we'll use pulverized lime and then we'll use a coarser grain limestone. Your pulverized lime is your immediate buffering of your pH. It's going to raise that up. But to maintain that pH and that buffering over time, we're going to use a coarser grain product. So with pH on the y-axis and then months after liming on the x-axis, you can see with the coarser material, you're maintaining that pH buffering over time. So by kind of figuring out what works best for your system, that's kind of one important thing that we've done over time. Other amendments include fertilizers. We use a 462 product locally grown or locally created in Colorado. It has biochar in it as well as mycorrhiza, which is a fungi component. Organics such as biosolids from wastewater treatment plants, seed, mulch, and then local slash if you have it on site. And then kind of putting this all together, you can create a self-sustaining and soil regeneration over time, getting that A horizon to develop after that the organics degrade and kind of come back up through plants. So soil sampling approach, understanding your baseline conditions is kind of the first thing you need to do at the site, whether that's the water quality or the soil quality and chemistry to understand the site conditions. Usually whenever we come into a site, it's going to be a 30-point composite sample because you want to kind of figure out not just one spot on the site, but what does the whole site look like. And we'll do this through random 30-point composites. This is done through X-ray fluorescence, XRF, field leachate test, and then taking those 30-point composite samples and having 10% lab verification to make sure that your results are jiving together. This is an example of a project I'm going to talk about shortly, but the Atlas Mine and Mill. This is kind of a random 30-point assembly on the red tailings and then down on the gray tailings. So just an example of how to just randomly pick sites and then GPS them so you have that. And then the Mini Lynch Mine, we had 9 mine waste piles at this site and GPSed each of our mine waste piles here. So kind of showing how we'll usually lay out a site when we come in. The soils are lab analyzed for total metals, acid-base accounting, sulfur forms, pH, organics, NPK, and then T-CLIP, which is toxicity characteristic leaching procedure, which is important whenever you're kind of defining what the contamination pathways are to your groundwater. This is usually the suite of parameters that we'll usually go after when we come into a site. Field leachate test, which I mentioned earlier, shows dissolved metal runoff potential via surface water pathways from the waste rock. So you can kind of calculate what your 2-hour, your 24-hour, 50 and 100-year rainfall events might be and what was going to come off your mine waste pile so you can prioritize some of the bad actors in the watershed. We then compare the total metals to ecological or other human health screening levels for other site prioritizations. And then there's also metal threshold calculations that you need to take into account on whether phytostabilization can be used at your site. This is usually the sum of lead, arsenic, zinc, and copper. And it would be if you have summations less than 2,000 ppm or milligrams per kilogram, that's an easy phytostabilization site. 2,000 to 3,000 is going to be a little bit more difficult. Extra lime is going to be required. And anything over 3,100 might be a candidate for a repository like I previously mentioned. So amendment calculations, these are really important whenever you're trying to put together your site plan and trying to nail these down. I'm going to reduce the mind-numbing chemistry this late in the day and just tell you to refer to Sobek or Cravata for some lime rate calculations. But acidity produced from iron sulfide or pyrite is neutralized by 2 moles of calcium carbonate. Kind of from this equation down here that we see. But what that means is 31.25 tons of calcium carbonate will essentially neutralize the acidity from 1,000 tons of rock with 1% weight pyritic sulfur, or acid-base accounting methods. And what do I mean by acid-base accounting? It's the difference between the neutralizing and acid-generating portions of the waste rock. So that's one of the parameters I previously mentioned that we'll look into. And some examples, so if you have a negative acid-base accounting number, that means your waste rock or tailings going to generate acid when it weathers or comes in contact with oxygen and water. Just a general unit would be negative 10.8 tons of calcium carbonate per kiloton of pyritic waste rock. So using that and applying that to test plots is what we'll usually recommend. And going back to the Atlas mine, this site is outside of Uray, Colorado in southwest part of the state. It's at about 10,500 feet elevation above sea level. The footprint of the site is about 8 acres. This part of the red tailings is about 3 acres, and then this part is 4 acres with about 24,000 yards of material. And what we did for this project and for the Snowbird project was develop a spreadsheet with EarthFacts Engineering. They're based out of the Salt Lake area, to calculate what the lime rates need to be on site. And the lime is important to control metal mobility from those water-soluble metals. The concentration of those metals decrease by orders of magnitude as you raise and you buffer the pH. Some things that just kind of zero in, the ABA here, the -5 and the -12, come down into the actual rate. So they kind of let you know what the tons of lime and limestone required to remediate and essentially buffer the red and the gray tailings at this site are. So that's a lot of material to think about. So you need to shrink it down into a manageable level. So what we usually do is put them into 25 or 100 square foot test plots to make a real world example on site, not taking the material and bringing it into a lab, but leaving it out in the field and conducting test plots where your actual reclamation is going to take place is really important to see if you can establish that native vegetation component. So applying those results to test plots in the field. The red tailings that I mentioned, some baseline and background conditions, has a pH of 3.4. It has high lead and high arsenic. This is what the sites look like before. You can see there's no vegetation, just a barren landscape of waste rock and tailings. We'll refer to them as R2, R3, R5. During amendment incorporation, and R2 amendments had 20 pounds of powdered lime, 2.3 pounds of compost, and 1.15 pounds of our fertilizer. R3 had 15 pounds of limestone, 1.15 pounds of fertilizer, and then a 1/4 inch of compost coverage. And then R5 was kind of the control site. We didn't use any lime or limestone, and it just had fertilizer on it. This is after mulching with native seed, followed by wood straw. And then this was also done in late September of last year. And then this is showing the results of the test plots this year in July. So obviously seeing pretty good establishment of vegetation over that one growing season on site. We had about 85 to 90% coverage at R2, 65 to 70% coverage at R3, and about 50% vegetation coverage at R5. And then this photo was taken a couple weeks ago when I was back on site, so showing that the vegetation continued to grow over the summer, over the monsoonal events, and we didn't get any phytotoxicity or vegetation die-off over that part of the year. So just even more vegetation establishment on R2. So bringing this all into Snowbird and kind of using some of the test plots within their best management practices plan is kind of where I'm going with this. And to kind of take a step back in time, where did the partnership between Trout Unlimited and Snowbird begin? And it was in about 2003 in March. Trout Unlimited was interested in the American Fork Canyon and mine reclamation work, specifically in that watershed. All of the MOUs, or Memorandum of Understandings, were developed between TU and Snowbird, the Uinta National Forest, to be able to start doing some of the work in this watershed, with the intent to develop a demonstration project that would improve environmental conditions in the North Fork of American Canyon by reducing heavy metals to our cold water fisheries. The Pacific Mine was identified as the site and the repository to house waste from 4 other mine sites in the drainage. This is what the site looked like before. We had fluvial tailings down here where the old mill site used to be, as well as waste rock up here in the upper part of the site. And the 4 sites specifically used as part of this project was the waste rock pile, the mill site, Blue Rock mine site, and then the Scotchman number 2, which was down valley more. This is after completion of restoration at the site. A passive treatment wetlands, series of wetlands was installed downslope of the repository shown here, where all of the waste rock from these sites was located and kind of consolidated. So applying these test plots to Mary Ellen Gulch. Mary Ellen Gulch is on the south side of Snowbird's property. It's where their proposed expansion plans are. So they wanted to kind of quantify the abandoned mine land problems that they potentially have on that part of their property. So 3 years ago, I was brought in to work with Snowbird and brainstorm how we might try to come in and do best management practices on their mine sites, which are the Globe, the Live Yankee, and the Silver Wave mine. This is looking down valley during that visit. This is the Globe mine with a lot of the mine waste piles, with the creek running right on the right side and abutting a lot of those mine waste piles. So Snowbird came up with best management practices in 2018. With this map, kind of focusing on the purple polygons, there's 8 mine waste piles that were identified through this BMP process. And then the green little polygons were sites where we figured test plots would be a good option to see if revegetation directly onto their mine waste piles would be a good option. In July 2018, we did 30-point composite sampling at those 8 mine waste piles, a full suite of metals analysis that I had previously mentioned, and then a field leachate test for site prioritization. We installed test plots in September 2018, as well as other BMPs, to kind of reduce erosion into Mary Ellen Gulch. So some results from the test plots. Site 4 specifically, which is right here, a little bit lower down in the mine complex. This is right after incorporation of amendments in September last year, and then this is this year in July of 2019. So pretty good establishment. They didn't put the amendments the whole way around the perimeter. It's just kind of within where the vegetation is growing. So about 80% coverage on Site 4. And then this was continued development of that veg in September of this year. Site 2, right after incorporation of amendments, and then almost 1 year later. So again, really good establishment showing that phytostabilization in a lot of these mine waste piles on their property is a good option. And then I really like these photos. It just kind of puts it in perspective that whenever you look down a heavily degraded area from historic mining and you can see vegetation growing on a mine waste pile, it kind of looks out of place, but it gives you the hope that you can do that along the whole drainage if conditions can persist that way. Some continued test plot photos at the Silver Wave, and then later in September, Site 9, this is along the road. There weren't really any lime amendment rates used for this one, but the fact that this was a corridor for erosion all the way down into Mary Ellen Gulch, it was kind of important to try to establish some vegetation along this site. And then some other BMP results. The live Yankee is kind of the elephant in the room at this site. It is the big draining mine. It drains perennially at about 0.17 cubic feet per second. Previously, it was a big, large disturbed area where flow went across the waste rock pile, generating non-point source contamination into Mary Ellen Gulch. Vegetation establishment was performed through the BMPs, and then restricting vehicles and off-road vehicles on the site helped reduce erosion. So before, or right after they did the revegetation, and then after in July 2019, you can see keeping this mine water away from the waste rock pile and consolidated in one stream is going to help the water quality conditions in that area. Natural vegetation establishment along Riparian Road, which I previously mentioned. And then erosion control devices or wattles along the base of mine waste piles has also helped reduce erosion. So some next steps. This is one of the live Yankee mine waste piles. I'm standing on the south one. This is the north one. It's about 50,000 yards of material, so it's going to be a pretty important part of the next phases at Snowbird and what to do there. But I was part of a recent meeting with EPA regional staff in August to brainstorm and see what our next steps were going to be in a long-term plan. These discussions morphed in with regional Forest Service staff to kind of try to quantify the full extent of contamination on federal lands as well. So this is a mixed ownership group site, and working collaboratively, which we've heard today, is a big thing for the completion of a lot of these projects. So this will be no different on this one moving forward. Continued monitoring, part of Snowbird's permitting process. They have to meet the NPDES permit, water quality monitoring that they have to do for monthly monitoring from the live Yankee as well as down Mary Ellen Gulch. And in 2019, the rest of this year, we're planning to install a partial flume for flow monitoring coming out of the live Yankee to see if there's any fluctuations in that adit flow. With the partial flume, we'll have some data loggers, and then we'll do water quality source bracketing along Mary Ellen Gulch to kind of see and prioritize which of those 8 mine waste piles might be loading more metals to the watershed than others. In 2020, they'll be doing some physical closures on site. There are a couple open holes that are a little bit of concern. That'll be done in conjunction with Division of Oil, Gas, and Minerals. A study for the field leachate test to quantify how much non-point source is running off of the pile. And then some soil cement test plots. So these are a pretty interesting project or product where it can be applied. It's a polymer and it's applied in a spray to the mine waste pile, and then whenever rainfall or snow would come down on the pile, it wouldn't generate contamination because it would almost create a barrier between that and the mine waste. So we're going to do a couple test plots with that and evaluate the effectiveness on site. But really, in 2021, It's going to be assessing how these test plots and the phytostabilization test plots kind of have evolved over time, and see if that's an option for revegetation in the live Yankee as well as a lot of the sites around the south side of Snowbird property. So just like to conclude with that, and thank you for having me and open it up for any questions. But our motto for our AML work is, it is clean enough for your dog. But this is a reclaimed site recently, and my contractor's dog and enjoying the fruits of our labor. So thanks for having me.
Thanks a lot, Jason. Any questions? Oh, right here in the front.
Do you, with this polymer phase that you're going into, is there any information? I looked into it about 15 years ago with my work. Didn't find any answers. Do they know how it affects soil microbiology?
It kind of depends on which product you're talking about. So soil cement was one we looked at, and that's more of the polymer, but there is another one called biocement, and it's actually urea. And whenever it mixes with the chemistry with the mine waste, it creates a calcium carbonate crust. So that has a little bit more of a biological effect. But the other stuff with regards to the actual polymer spray, I'm not too sure on it. We did just spray it at one of our other sites outside of Georgetown, Colorado, to kind of see how it works over the winter. But it's something that we're looking into.
Frank, you had a question?
Yeah, I have a question about vegetation. So when you're selecting vegetation to put on these plots, are you looking at both sort of their qualities as bioremediation, and also their ability to provide habitat to terrestrial wildlife?
Yeah, that's a good question, and I actually forgot to mention that. But the vegetation in the seed mix that we'll select is site specific, and I usually work with plant specialists to determine what that is based on elevation, growing season aspect, all of that type of stuff. So we'll usually do a cover crop the first year to get that vegetation to establishment, and then the natives to kind of come up after it. But our seed mixes have probably 15 to 20 different species in them, depending on what that elevation is. So it is an important part of each project, and making sure we get that in there.
The back here.
Thanks, Jason, for a good talk. You mentioned pH manipulation to slow down metals. Sometimes oxygen in the pH diagram has a lot to do with how mobile things like chromium and uranium and things like that are, with higher oxygen being more mobile. And that's, your fish need by oxygen, but if there's by oxygen like mobilized metals. Have you looked at the redox conditions at all, in addition to pH manipulation? Is there any way to do that?
We haven't really looked at redox conditions for that. It's more just kind of, we'll monitor downstream of some of those sites, and some of these phytostabilization sites have occurred right along the banks of streams. We've done 80 acres of them in the Kerber Creek watershed, and have noticed significant surface water improvements post completion of some of these. And I think you have a good point that whenever you have such a stable, and when I mean stable, 60 years of mine waste sitting there, that's kind of consolidated on itself, and whenever you dig it up, you do add that oxygen component to it. So it's kind of important to know that the conditions might get worse before they get better, and having that pH come in and try to buffer the material is something to take into account, and whether or not it might be better. And that kind of goes into like the characterization part that I talked about earlier, right? Where maybe if you have a really, really acidic pH, high sulfidic mine waste pile, you might not want to try phytostabilization on it and put it into a repository. So it's kind of ranking that in that risk versus reward kind of scenario on whether you should try to do the in-situ work or not.
Is there a limit to the depth of the mine waste piles, or a characterization of the leaching that's going on? Because the phytostabilization is only probably what
We'll usually spec our depth, and the question was, doesn't matter the depth of the mine waste. We'll usually spec a depth whenever we're mixing of 12 to 18 inches. So the amendments are getting down into the soil fairly deep. And you're right, the root zone doesn't go down that far, but by creating that root zone, you're reducing the infiltration into the mine waste that might be down below it more. And then you can the other thing that happens when you do or incorporate the coarser material or the coarser grain limestone, it almost creates a capillary break between the underlying mine waste and the reclaimed soil on top of it. So then you're not getting that interaction between the mine waste underneath it and the good thing that you're kind of developing on top of it.
Any more questions? Okay, thanks, Jason.